Okay, hi everyone, and welcome to Causation 2. So our first speaker will be W Czarnowski with Transferring Novel Causal Knowledge.
Hi, everyone. Today I'm going to be talking to you about transferring causal knowledge across category levels. Unfortunately, I have COVID, so I can't be there in person, but please bear with me. Anyway, imagine you're out gardening one day and you notice that all of your pink roses are wilting. So being the responsible gardener that you are, you begin searching the internet to see how you can bring your pink roses back to their prime. And that's when you learn that used coffee grounds can be used to treat wilting in pink roses. So you go out and sprinkle the remnants of this morning's coffee onto the soil around your pink roses and hope for the best. The very next day, you go out to check on them and you see that your pink roses are looking fantastic. But as you're walking back inside, you notice that your red roses look unhealthy. So you think to yourself, how far will this miracle cure go? Will it work on your red roses? What about your tulips? Or how about your cactus? Would it even work on an ailing oak tree? Asking these questions requires you to transfer your knowledge of how a cause, the used coffee grounds, produces an effect, healthy pink roses, to various novel situations. So people regularly generalize knowledge to novel contexts, but how they go about doing so often depends on the situation they find themselves in. Analogical reasoning, for example, is useful for transferring knowledge between specific instances. And we do this by identifying common relational structures between two analogs and then map our knowledge of the familiar analog onto the structures of the unfamiliar one. So consider the water model for electricity. By recognizing that the flow of water through a pipe network corresponds to the flow of electricity through an electrical circuit, you can use your knowledge of, say, water pressure to guide inferences about voltage. But knowledge is also transferred more broadly, such as to or from entire categories. So category-based induction is the use of category knowledge to infer properties of novel category members. For example, suppose you know that all birds have a particular anatomical property. If someone presents you with a bird-like animal you've never seen before, you can use category-based induction to infer that this novel animal might also possess that property. Across both styles of reasoning, researchers have focused on principles such as similarity when people decide to engage in knowledge transfer. If two situations appear to be similar, one might believe them to be analogous and so use analogical reasoning to navigate them. If a novel category member is highly similar to a known category exemplar, one might be willing to infer properties of that category in that novel member. And principles like this have been thoroughly researched, but in our work, we're interested in whether shared causal relations can serve as a basis for knowledge transfer. Though a causal relationship exists if the occurrence of one event causes another. So if we administer used coffee grounds to our pink roses and our pink roses become healthy, we might infer that the used coffee grounds caused the pink roses to become healthy again. But there is more to causal reasoning than asking, did A cause B? Various kinds of causal information make up the causal relationships we understand in the world. First, causal mechanisms serve as the process by which the cause brings about the effect. Perhaps used coffee grounds promote pink rose health by increasing the nitrogen content of the soil. Now, we also have causal strength, which is a measure of how effective a cause is. Maybe the used coffee grounds are a strong cause in that they always produce healthy pink roses. Or maybe they are only a moderately effective cause and only produce healthy pink roses some of the time. So if we put knowledge transfer and causal knowledge together, we're brought to our research question. Will people transfer knowledge of causal relations to novel situations? So to examine this, we conducted two experiments, each one focusing on a specific piece of causal information. To see how we measured this transfer of causal knowledge, I'll walk you through some sample materials. So participants were provided with various scenarios that described a cause producing an effect in a specific instance of a category. The item in the scenario was always a subordinate level category member. And all experiments used the same scenarios, but the to be transferred piece of causal information included in the scenario was changed for each experiment. So in this example from the causal mechanism study, we see used coffee grounds being administered to pink roses, which causes them to become healthy again. And increasing the nitrogen content of the soil is the causal mechanism in this scenario, which serves, again, as the piece of causal information that would eventually be transferred to other category members. So after reading through the scenario, participants were then provided with prompts that asked them to transfer the causal information to various category members, which I'll refer to going forward as transfer targets. So in this example, The transfer prompt is asking how likely you believe that used coffee grounds will produce healthy tulips, the transfer target, via the same mechanism that produced healthy pink roses in the scenario. And transfer targets were exemplars from various category levels of the hierarchy that the subordinate level item in the scenario belonged to. So now let's look at some of these transfer targets for the pink rose scenario. So this diagram contains example transfer targets for each category level for the pink roses scenario. I've drawn lines to signify which categories are subsumed by higher order categories. At the subordinate level, we have red roses serving as a transfer target. Moving up to the basic level, we have roses and tulips. And at the superordinate level, we have flowers and trees. Up at the top, we have earthworms in a different superordinate level. In each scenario, we included a single item that did not belong to the category hierarchy that the scenario item belonged to. This was done as a control, as we would not expect people to transfer causal information to an exemplar that had very little, if any, properties in common with the item in the scenario. Excuse me. In addition to manipulating the category level of the transfer targets seen on the previous slide, our second manipulation was varying the domain that the scenarios belong to. So we created 4 scenarios for each of the 3 different domains: natural, health, and mechanical. In addition to measuring participants' transfer judgments, we also asked them to rate how similar they believed each of the transfer targets was to the item in the scenario. This served as somewhat of a manipulation check, as we would expect similarity to map onto transfer judgments. High similarity between 2 items should correspond with more transfer judgments, and vice versa. Overall, participants were presented with 12 scenarios for each of the 3 domains. They're given 4 target items, and for each target item, they're rating similarity for 9 items throughout the category hierarchy. So for experiment 1, the transfer of causal mechanisms, we collected data from 55 participants using a 4x3 within subjects design. Prompts in each scenario followed the models that you see here, which task participants with determining the likelihood that the mechanism from the scenario would apply to the novel item. And again, within each of the 3 domains, participants were provided with 4 scenarios and made judgments for transfer targets that spanned the 4 category levels: subordinate, basic, superordinate, and a different superordinate item. But what might we expect to find? So people might not transfer causal mechanisms at all. In the scenarios, we describe a specific cause producing a specific effect in a specific category member. For our pink roses, people learn that used coffee grounds are associated with healthy pink roses because they increase the nitrogen content of the soil. It's possible that this might lead people to believe that pink roses possess some unique property that causes them to wilt when they are nitrogen deficient, which explains why used coffee grounds are an effective treatment on pink roses. If that were to be the case, people might not believe that the other transfer targets possess this property, so they won't transfer the mechanism because only pink roses possess the property that the cause acts on. Or maybe people will transfer causal mechanisms up to a certain point and then stop transferring them. If people believe that the causal mechanism acts on a property that is possessed by all members of a basic level category, then they will transfer that mechanism to all members contained within that category, and then stop transferring it once the transfer targets move outside of that category. So if that nitrogen deficient wilting property is unique to all roses, then participants should transfer the causal mechanism to all targets that fall within the category of roses. Transfer targets that are not a type of rose must not possess that property, so transfer judgments will immediately plummet once they move outside of that basic level category. Pardon me. It's also possible that we observe a decreasing pattern in transfer judgments as we go up the levels of the category hierarchy. At the subordinate level, category members possess specific individuating properties, but at higher levels, the amount of specific shared properties decreases. Pink roses share some properties with roses, which share many properties with flowers, which share most, if not all, properties with plants. When comparing pink roses to all roses, and then to flowers in general, people might be sensitive to this decrease in shared specific properties, so they will be less willing to transfer a causal mechanism to increasingly abstract category members due to the decrease in relative similarity. So what did we find? So on this x-axis, we have our 3 domains: natural, health, and mechanical. And on the y-axis, we have mean transfer judgments, which were made using a 1 to 7 scale, where 1 represents not at all likely to transfer, and 7 represents extremely likely to transfer. Our analysis of variance revealed significant main effects of category level and domain, as well as a significant interaction. So let's step through some means. Here, we have the natural domain. We're seeing the highest amounts of transfer for subordinate level targets with a significant decrease in transfer judgments between each of the other three category levels. This pattern of decreasing transfer judgments as we go up the category hierarchy suggests that people are less likely to transfer causal mechanisms, to increasingly abstract transfer targets. So now let's look at the health domain, which you see here. We're seeing pretty much the same exact pattern of transfer, but to a slightly less degree than what we observed in the natural domain. And now the mechanical domain. In the mechanical domain, transfer judgments for subordinate and basic level targets were not significantly different, and transfer judgments for superordinate level targets were just barely significantly different from the basic level targets. So just to make this a little more tangible, this would be like transferring from an iPhone to an Android and then from an iPhone to a laptop. So this pattern of means suggests that when transferring causal mechanisms in this mechanical domain, people are not differentiating between the subordinate and basic level transfer targets to the same extent that they are in the natural and health domains. But overall, we're seeing that transfer judgments do decrease as you go up the category hierarchy, but the pattern of decrease in the natural and health domains differ from what we're seeing in the mechanical domain. So on to experiment 2, we're looking at whether people will transfer the causal strength of the mechanism. This experiment was identical to experiment 1, except for some changes to the stimuli, which I'll show you on the next slide. So in experiment 2, the stimuli were very similar to those used in experiment 1, but now the to-be-transferred piece of causal information was the causal strength of that mechanism. So in all scenarios, the mechanism was described explicitly as being a strong cause, and the mechanism information was only included in the scenario and was not seen in the prompt. So the transfer prompt is now asking people to judge how effective they believe the mechanism would be at producing the effect in the various transfer targets. So what did we find? On the x-axis, again, we have our 3 domains, but on the y-axis, now we have a 0 to 100 scale instead of a 1 to 7 scale. So when measuring causal strength, it's the industry standard to use a 1 to 100 scale, so that's why we used it here. And on this scale, a 0 represents that there is no relationship between the cause and the effect, and a 100 represents a perfect relationship between the cause and the effect, meaning that the cause will always produce the effect. Again, we found significant main effects of category level and domain, as well as a significant interaction. In the natural domain, we're seeing the same thing we saw in experiment 1. Transfer judgments decreased as you go up the category hierarchy to more abstract transfer targets. In the health domain, same thing, but again, to a slightly less degree than what we saw in the natural domain. And in the mechanical domain, we're seeing a similar pattern that we saw in experiment 1, except now there was no significant differences in transfer judgments between the subordinate, basic, and superordinate levels. But once again, we're seeing that transfer judgments decrease as you go up the category hierarchy, but the pattern of decrease in the natural and the health domains differs from the mechanical domain. Across both experiments, we're seeing that people are transferring causal information across category levels, but patterns of transfer in the natural and health domains differ from the patterns of transfer in the mechanical domain. So this difference could be attributed to differences between arbitrary and non-arbitrary categories. The scenarios in both the natural and health domains dealt with natural kinds, whereas the scenarios in the mechanical domain dealt with artifacts. As categories, natural kinds are special because they possess rigid category boundaries. Artifacts, on the other hand, are much more flexible in terms of how they are categorized. So we might be observing similar patterns of decreasing transfer in the natural and health domains because the categorical difference between a pink rose and an orchid, for example, is much more meaningful than the difference between, say, a Laserdisc player and a DVD player. And we've also tested this transfer of causal knowledge with intended effects and side effects, and we find the same pattern of results for both. But a lingering question we have is whether we can fully separate category level and similarity. I didn't present the similarity data here for the sake of time, but similarity judgments in the mechanical domain did not perfectly map onto people's transfer judgments. While transfer judgments across both experiments showed that people are not differentiating between the subordinate, basic, and superordinate transfer targets in the mechanical domain, patterns of similarity judgments followed the stepwise decrease across category levels that we observed in the natural and health domains. Now, this is quite the conundrum. When it comes to similarity, people are distinguishing between the category levels of the mechanical domain, much like they would in the natural and health domains. But when asked to transfer this causal information across those same category levels, we see that homogenization of the subordinate, basic, and superordinate levels. So there's something beyond mere similarity that's driving these transfer judgments, at least in the mechanical domain, and I think that deserves further exploration. And last, I think we need to explore when people won't transfer causal information at all. In all two experiments, transfer judgments for the different superordinate transfer targets suggested that people are still willing to transfer causal information to a certain extent. Now, this is kind of weird. If sprinkling used coffee grounds on the soil is able to produce healthy pink roses, a plant, why would someone think that sprinkling used coffee grounds on the soil will also produce healthy earthworms, an animal? Exploring when people won't transfer will be important to establishing boundary conditions for the effects that we're observing in these studies. Thank you all for listening. Are there any questions?
Thanks for this really cool talk. This is such interesting work. I'm wondering about one thing that gives me a little bit of pause in terms of how to interpret that, and that's the fact that it seems like you used familiar causal mechanisms, and that raises the possibility that there could be differences in people's background knowledge about the generalizability of these mechanisms. So for example, if I think about something like gardening, some basic gardening knowledge would lead me to maybe know that nitrogen tends to be in a lot of fertilizers, and so I might be more likely to generalize that. And it could be potentially that maybe people are less familiar with the mechanisms that you described about in the mechanical domain. And a lot of research on category-based induction uses blank or novel properties for this very reason. So I'm just wondering if that's something that you're looking at in current work, or if you have some additional data that might speak to this. And thanks for this talk.
Thanks for your question. So yeah, we've actually, my advisor and I, Jessica Marsh, she's in the audience. We've thrown around about 15 different branches to take this line of work to look at things exactly like that. So one possible follow-up would be to ask people to give rationales or explanations for the ratings that they made. Another thing we did do in this work, but again, did not present it here, is we asked people how familiar they were with each of the topics that were covered in the scenarios. So quite verbatim, we asked people how familiar they were with gardening at the very end. And we sort of cross-referenced people's responses with those familiarity judgments, but we didn't really see any strong patterns. That being said, I think it is interesting to sort of ask for that more naturalistic explanation for why someone would make the judgments that they did.
Hi, thanks for a really cool talk. What do you think of the idea that transferability of causal claims can be explained, at least in part, by the fact that people view causal claims implicitly as summaries of just sort of like natural laws, right? And you might think that those natural laws are relatively few and that they sort of give us a kind of counterfactual semantics where it's like, if we'd done this thing differently, this thing would have gone differently because it's all governed by a law. And if you think that, then you might think, well, surely these two cases that aren't too different, you know, they both involve living things, they both involve living things that live in the same kind of place, you know, earthworms and pink roses. And so you might think, you know, they have to obey a similar dynamics. And so I can export this sort of fairly coarse-grained description of what's going on in this one case to this other case. And it should work because we can't have too many physical laws, and the physical laws that are here should work similar ways in similar contexts. So what do you think about that sort of like broadly sort of nomological gloss on people's ability to export and transfer causal claims from one domain to another, if those domains are similar enough?
That is an excellent question. I don't know if I've taken enough philosophy classes to really produce a good answer, but I think that if people think that like some universal law or some natural law is the path of least resistance, if you will, to understanding a situation, I think that, yes, they will default to basically just lumping those things together, like, oh, earthworms eat dirt, plants get nutrients from dirt. Those two things might sort of map onto each other and be similar. At the same time, I think, which actually kind of gets back to the previous question, like the more nuanced knowledge that people have that sort of provides exceptions to those natural laws, I think people will get a little less promiscuous with the how far they're willing to go when transferring this knowledge. Currently, the data we've collected so far doesn't really have a good philosophical answer to that question, but I think that's a very interesting perspective to look at in future work. Thank you.
Okay, thank you again. The next speaker is Elizabeth Lapido, who will talk about clarifying the logic of a classic control of variables task.
All right, thank you so much. I'm going to go ahead and set this up.